Kalai Ellis had the kind of magical childhood you might imagine for someone growing up on the island of Oahu.
When I think of my childhood, I think of mountains, oceans, and rain, waking up to cool, misty mornings. Every morning when I woke up, I would see the ocean. I could see the mountains. I could see the valley. Everything is connected. They're connected by the flow of water. When the rain clouds gather at the top of the mountain, the rain falls and gathers into streams, which lead into rivers. And those rivers, as they flow through the valley, they empty out into the ocean. There's just this natural flow.
Welcome to the Why Magazine podcast, bringing you ideas, stories, and voices from Brigham Young University. I'm Whitney Archibald, and today we've got a story all about connections. The connections between water, land, and sea that Kalai Ellis talked about in the intro, but also connections between the people of the tiny Hawaiian island of Molokai and a team of engineers and biologists at BYU. They're all working together to take care of the mountains, reefs, and community of Molokai, and eventually other reefs and other communities across the world. This episode is based on the article Mauka to Makai in the spring 2023 issue of Why Magazine by Brittany Carford-Rogers and Julie Harker-Walker, which means you can look it up at magazine.byu.edu to not only see some pictures of the Molokai reefs and read more about the project, but you can also watch a video with sweeping footage of the terrain we're talking about and see the research team in action. Here to tell us this story is recent grad student Kalai Ellis, one of the key members of that BYU team who has a special connection to the island of Molokai himself. A great-grandmother who is also committed to protecting the balance of community, land, and sea. Although she passed away a few years before he was born, Kalai grew up hearing stories about his dad's grandmother, whom they all knew as Molokai Grandma.
We just barely missed each other. But she was a woman that was, firm in the faith. She acted out of charity and love, and people respected her for that. People would ask her for advice or for help, say, oh, we should go protest this, or let's fight them, let's do this. And she said, no, you treat people with respect. And if you treat them with respect, they will treat you with respect, and then you'll come to a mutual understanding of what needs to be done. She did protest, but she always did it respectfully. She was protesting to get access for land. So a lot of times, land was being restricted or privately owned, and that was cutting off families from the ocean. And that's big, when you're living a sustenance lifestyle. They fish, they gather. It's not a big island. It's really small, limited resources. So when you cut someone off from their only food source, that's a problem.
Those problems that Molokai Grandma was protesting back then have only intensified in recent years, partly due to cattle ranching on the island. As cattle graze, it loosens up the soil and dirt. Then, when rainy season comes and pummels the mountainside with precipitation, the sediment just washes right into the ocean. This erosion causes obvious problems on land, from washing out roads to harming natural vegetation. But it also affects the ocean and the reef that protects the island of Molokai. Let's have Kalai paint a picture of this reef for us.
You have the coastline, you have the beaches along the coast, then you sort of have this coastal flats area where it's this even depth of water all the way out. And that's where a lot of seaweed will be and that kind of stuff. And then you start to hit this fringing reef, and it's this reef where it protects the south shore of the island from those waves. So a lot of times big wave surges will come in the summer, but once it goes over the reef, the energy slows down. I think it's magnificent. A lot of people that may have snorkeled, or you see pictures of these stunning reefs, like on National Geographic or Discovery Channel, bright reds, bright yellows, greens, blues. That's not the reef of Hawaii. The reef of Hawaii is a simpler reef, muted greens, maybe a couple blues, a little bit more browner, reddish, but it's still this reef that's just teeming with fish, that you can tell it's alive and vibrant.
But lately, the people of Molokai have noticed that the reef is less alive and less vibrant, and the once plentiful fish are getting more and more scarce. And when the reef isn't healthy, neither is the community of Molokai.
What's at stake when it comes to this reef is the loss of ecosystem services, the benefits that humans get from the natural world. Why do people enjoy hiking? Because it's beautiful. That's an ecosystem service, beauty. The mountains, what do the mountains do? Well, they provide beauty, but they also provide protection sometimes, right? In the same way that mountains can protect areas of Utah, the reef protects communities of Molokai. The reefs throughout the whole world protect coastal communities. And what's at stake is safety, health. The reef dies, and if it crumbles, then when strong storms or strong wave surges come, coastal communities get swept away. Not only does it provide that protection aspect, but it also is a place for fish and, shellfish, crabs, squid, octopi. It's a food source. It's the habitat for marine food sources.
As you may have noticed, Kalai Ellis, like his great-grandmother and his father before him, isn't the kind of person who sits idly by while this kind of ecological destruction happens. Kalai recalls the first time he realized he had a responsibility to the land. After a big rainstorm, his dad brought him along to help clean out some clogged drainage ditches.
My dad says, "Hey, Kalai, we're going to go out to the park. Can you help me?" And there's a part that had dirt, mud, sticks, trash, all this stuff just blocking the pipe, flooding the park. And then with the pole, we just went and we sort of shoved the pole through the pipe and tried to clear out as much of the debris as possible. And, for my dad, it's probably a really small moment and it's something that he does all the time. But for me, that was a time when things started to connect, where I said, I have ownership over this area that I live. There's a sense of stewardship and responsibility because, I'm part of that community. And then it really started to come together, I guess, towards like middle school, high school, when I took actual classes like biology that taught me like nature, this balance of things. And that just kept on getting reinforced as I learned more, as I studied, as I read, as I talked with people. We start to figure out our place in the world.
This love of learning led him to BYU and then to the biology department, where Kalai Ellis discovered a fascination for geospatial analysis, creating 3D models of geographical areas to study natural ecosystems, which came full circle and led him back to the Hawaiian Islands.
There was an advertisement for a Pacific ecology study abroad, and my eyes lit up and I said, "Whoa, wait, Pacific? I'm from the Pacific. I love the Pacific. Ecology, I love ecology. I love everything about being outside, in the water, connecting systems, all of that stuff. I'm going to apply."
I probably don't need to tell you that he got accepted into the program. So in the spring of 2018, he joined a group of students to study abroad in New Zealand, Samoa, and Hawaii to research how these different cultures approach conservation and to gather data about the health of the reefs in each area.
So they're doing these measurements, doing coral surveys, reef surveys, setting down fish cams to watch the fish, and you can count the fish. From that, you can estimate like biodiversity, like how many species are there, kind of stuff. And then I had read a scientific paper that talked about this platform where you could mount cameras onto the bottom of a bodyboard, a boogie board, and take pictures simultaneously. And then you can stitch those pictures using structure from motion, that photogrammetry software, and you make those models.
Making a contraption like this to be able to stitch those pictures together into a photo map of the reef would be a big breakthrough, not only for analyzing the current health of the reef, but for tracking it over time. So Kalai tapped into his inner MacGyver.
We're out there in Samoa, limited resources, and you had to get creative. So I had all this like guesstimate kind of thing going on, and we just lashed together a rig. So think inflatable paddleboard, PVC pipes, some T-joints, some action cameras, and we just hit start and hoped for the best, and we started swimming in that lawnmower pattern where it was full manual. Literally just like a kickboard, like at swim lessons, like swimming laps, back, turn back, turn back. We did that for 4 of them, and 1 out of the 4 actually stitched. Had zero expectations for this, and it worked. So then we said, okay, proof of concept. Now we can actually start putting in some more effort.
So when Kalai went back to Provo in the fall, he enlisted the help of more students to create a better prototype to try out during the next year's study abroad. Like the first rig, this one was totally propelled by the students themselves, who kicked the floating cameras back and forth over the reef. It was on this second study abroad trip that Kalai got his first introduction to an organization called Aina Momona, a nonprofit community organization dedicated to protecting the ecosystems on Molokai. Some more connections here. The president of BYU Hawaii, Keone Kawe, who grew up on Molokai, sits on the board of Aina Momona. He reached out to Richard A. Gill, a professor in the biology department at BYU and program director for the Pacific Study Abroad, to begin a partnership with Aina Momona and do some geospatial mapping of a section of land on Molokai. Gil, in turn, invited Ellis to join him on the project as a grad student.
He started telling me about the project working with Aina Momona back on Molokai, doing some drone mapping, which I love drones. And I thought it was really cool that I'm able to connect my passion in drones to conservation, to mapping.
So in 2021, Kalai Ellis and Richard Gill headed back to Molokai with some drones this time to gather high-resolution images of the mountainside. They flew them back and forth low to the ground in an overlapping pattern, again like a lawnmower, over about 1 1/3 square miles.
Imagine looking up at a mountain in Hawaii and you see the trees, you see the hills, you see this dirt road, you see sort of grassy plainish areas, but all on a slope. That's the kind of area we were mapping.
Okay, so something that would be very hard to do on foot.
Yeah, something that would be
impossible.
Just an absolute pain.
Yeah.
It would take, days, hours, tens, hundreds of people to do that kind of mapping. But the drone, toss it up, you fly it for a couple hours, and it still took us, maybe 30 hours of flight time. But compared to thousands of man hours, this is such a big improvement.
Great. So what was your main objective there? What was the problem you were trying to solve?
We came in hoping to guide management, hoping to assist in the management and collaborate with them to figure out, okay, so they know they have this issue, dirt coming off the land, entering the ocean. How do we solve it? Well, you solve it by, mitigating erosion, by creating berms, by creating deposition pools, areas for sediment to collect, by replanting, revegetating, or even by making the case that, grazing by cattle is harmful. So that's our hope. Our hope was to provide the tools, the maps, the resources, the quantitative analysis to support the qualitative stories, data, words that the local people and land managers had.
Great. So have they been able to take some action based on this data so far?
Yeah, so they took all of the data that we've collected, they took our maps, and they are putting in those erosion mitigation berms, trying to redirect stream and water flow to slow down water. So it's going on. It's super, super exciting that they took all of our land stuff and have started to implement it.
Clearly, the team was seeing some big wins for the island. But what about the rest of the picture? What about the ocean and the reef? The land mapping gave them more insight into that as well. When compared with mapping from 2 years earlier, they estimated that in those 2 years, 2,000 square meters of soil had moved from the mountainside to roads and the reef, approximately the amount that would fill an Olympic-sized swimming pool. That's a lot when you picture it all together, but now...
Imagine it being spread out in a thin layer all across a reef, blocking sunlight from getting the reef, making the water cloudy so things that need to photosynthesize are unable to. It's a scary thought, but it's also something that helps motivate you into action.
So Kalai Ellis and Richard Gill knew it was time to do just what the water does, move from the mountain back to the sea, back to those kickboard prototypes. But this time, they wanted to kick it up another notch. It was time to call in the engineers. They partnered with BYU professor Joshua G. Mangelson and the Field Robotic Systems Lab, known as the Frost Lab, to create a motorized aquatic robot that could function basically like the drones did to map the land, systematically taking images in overlapping patterns to create more precise 3D maps of the reef. They built and tinkered some more, getting the robot ready for Molokai. And since they built the robot in Utah, so far from the ocean, they had to get creative to make sure it would actually work. I asked Kalai, after all this work, were you nervous about whether it would work?
So stressed. We did our field trials up in the Uintas. Up at Mirror Lake, we got the robot out and just tested, okay, does the automation to take pictures work? Does it gather water quality sensor data? Do all the pictures feed back to the field laptop? Does the robotic navigation work? We did field trials in the different testing pools at BYU. We were testing this thing extensively. And the engineers especially, they were testing to make sure it all worked. They would take it out and just sort of push it on a dolly around campus just to see if the GPS is pinging. You have this meter long yet bright yellow robot boat, but they're just pushing this on this dolly testing.
I would have loved to see that rolling around campus. Then when they were satisfied it was ready for the open sea, they booked a trip to Molokai for the whole team, 50 people strong. And they sent their creation on a barge to the islands. But...
Well, we get to Molokai and we go to pick it up and it's not there. Never got delivered.
Oh.
And now we're panicking. We're like, oh my gosh, like, and we're just calling and we're panicking and we're seeing where it is. And then we find out it's back on Oahu in a warehouse waiting to get onto the next barge. The next barge doesn't go out to Molokai for a couple more days. And we're thinking, like, every day that we don't have our equipment is a day lost. Like, this is big problem. And this is, blessings of family and blessings of community of people to help. And my dad's on Oahu, and I call him like, hey, Dad, can you go down to the harbor right now? Can you get this on the next flight out? Like, we need that pallet. And he said, yep, I'll be down there in half an hour. And my dad, I'm so grateful for our family that he was able to go down, find the pallet, drive it over to the air freight service, and said, it'll be there next morning, be at the airport to pick it up.
Amazing. That's great.
And it was just, where we got it. And, as soon as it touched down, we had everything ready. Like, we knew, okay, the biology group we'll go to the airport, pick it up. The engineers need to have all their laptops set up, ready to connect and stream and connect. And we just went to action and we got it to work on the first day. So grateful for that. And we were honestly just so blessed because when it got out into the ocean, we had perfect conditions, which never happens in research, where we go out and we needed the water to be flat because we weren't sure how the boat was going to do in big waves. Water was crystal clear. Water was perfectly flat. No wind. Like, everything that could go right went right for us at that specific time. And that is
that's so cool.
Amazing. Yeah.
For the next several days, the team continued to collect photos and samples of water and sediment. They made adjustments as they learned how to best use this new technology. Here's an example of one day on the reef.
Wake up, 5:30, load our truck, go down to the harbor, get on the boat, load up the robot. And the robot is the most bulky, inconvenient thing ever to move. It's just such a weird shape, weird weight distribution, and we have to be careful because there's all these electronics aboard it. The boat is not a massive boat by any means. It's maybe, captain's piloting the boat in the middle. There's some space in the back, some space in the front, and everyone's just trying to find a seat. We're going out there with the engineers, and the engineers are actively coding on the open ocean on a field laptop while I'm in the water with the boat, making sure that, it doesn't drift too far. And they're saying like, okay, Clay, hold the robot closer to us. We're trying to get the data link connected. We're trying to see if transferring works. And then we say, okay, like, everything looks good. We hit start and the boat starts going. And then there's actually a time when we're like, I think we can run this battery all the way down to like 5%. Never a smart idea. But the boat starts going. And then all of a sudden they say, oh my goodness, the voltage dropped. The battery is depleted. The motors aren't working. So I grab my fins, I grab my mask, and I'm just like, well, it's a good thing, the current's not too strong. It's a good thing that the boat's still relatively close, but it's still like a 20-minute swim to go out and retrieve it. So that's, it's funny. It happens. And we learned our lesson and we grew.
The team successfully mapped the sections of the reef they wanted to study and brought the data they collected back to BYU. And they continue to analyze and study the photos and biological samples they collected to learn more about and monitor the health of the reef. Meanwhile, engineers continue to improve the robot rig.
That's something that we're still pioneering and we're still working through. And it's just continuing. How can we optimize this? Or how can we actually make it so that it's usable for the average person? The dream in all of this is that how can we put all of this awesome technology into the hands of the community, into the hands of people that live there day in, day out? How can we empower them with this technology?
Although the individual members change, the community of biologists and engineers at BYU and the community members of Aina Momona and the Molokai Land Trust continue to work together. Now that he has graduated from BYU with a PhD, Kalai is mapping out the next stage of his career, choosing between several different academic research positions in his field. Whatever he chooses, Kalai feels like his experiences at BYU have prepared him to meet challenges, solve complex problems, build community, and most importantly, make connections.
Like in the moment, I was going through these stressful situations, just thinking, okay, just take it day at a time, just take it hour at a time, just take it, minute at a time sometimes. But it helped all of us grow so much. We grew as people. We grew in being more compassionate, in being steadfast, in being patient, in being faithful. We grew literally in every aspect. You know, when you get put through that like fire, you grow. It's sink or swim. And happy to say we all swam.
Thank you for listening to the Y Magazine podcast. This episode was based on an article in Y Magazine by Brittany Carford Rogers and Julie Harker Walker. This episode was produced by me, Whitney Archibald, executive producer Denya Palmer, original music and audio mixing and mastering by Jarrett Davis, and special thanks to Kalai Ellis for sharing his story.